Hello dear students, I heartily welcome you all in the video lecture series on structural analysis 1. So as we are dealing with unit 3, that is module 3, fixed beam. So in today's second lecture on fixed beam, we'll continue our discussion on propped cantilever, that is indeterminate beams. So objective of this lecture is that after the completion of this video lecture you would be able to know about propped cantilever and you can analyze the propped cantilever beam. So as we were discussing on propped cantilever, so let us consider a propped cantilever, but we know that if the beam is simply cantilever, we can analyze the reactions by simple equations of static equilibrium, that is summation of vertical forces equals to 0 and summation of moments equals to 0, right? Now what will happen in case of propped cantilever? Yes, you can say what difference between cantilever and propped cantilever? Yes, in propped cantilever the free end will be supported by an additional support. So the analysis of propped cantilever involves in additional equations, and as we know the degree of static indeterminacy for the propped cantilever is 1. How is 1? कहाँ से आया 1? Yes, as we know degree of indeterminacy can be defined as the forces on the beam equals to number of equilibrium equations or static equations. So in case of propped cantilever, number of equations are 2 and forces are 3, as 3 minus that 2 equation will become 1, and static indeterminacy we can say for propped cantilever as 1. Okay, now what will happen if we add additional support to a cantilever as a prop? It results in additional equations for the analysis of propped cantilever, and these equations are obtained from the consideration of slope or deflection at some particular point. Now this consideration of slope or deflection for the calculation of extra support reaction at a particular point is termed as consistent deformation or method of consistent deformation. Now let us consider a cantilever beam AB carrying a UDL W per unit length over entire span, and the cantilever is propped at end B as shown in the figure. You can see there is a beam which is propped at support B and fixed at A, subjected to uniform distributed load W, and the span of this beam is L. Now there will be 3 forces or 3 unknown forces: RB upward reaction at prop support, RA upward reaction at fixed support, and fixed end moment at A. So let in figure you can see RA, RB and MA, these are the unknown forces or reactions which we have to find the reactions at A and B, and MA is nothing but the fixed end moment or end moment at the fixed end A. Now these 3 unknowns require 3 equations to solve. Now assume that, but we know in our case there are only 2 equations. So to solve such condition, we will assume that the prop RB at B is removed, means at end B this RB is removed and it is subjected to only UDL in the form of simple cantilever beam, and this deflection of beam is allowed. Or in other case or case 2, we will assume it is subjected to prop at B, that is RB, and downward UDL is removed, and also this beam again is subjected or allowed to deflection. What will happen by assuming such conditions? You can see in diagram, there is a cantilever subjected to UDL. Now in first case we are assuming there is no prop force or prop reaction, that it will deflect like this, and the deflection at B will be downward deflection, YB will be downward. And if in a second case, as we assume, there is no UDL or no transverse load, but it is subjected to upward prop reaction, and also this beam is allowed to deflect. Now there will be upward deflection at end B, that is YB will be upward. Okay. Now if the prop and the fixed end A is at the same level, then we can say that upward deflection due to prop will be equals to downward deflection due to the UDL in case of cantilever. Or in other words, we can say the prop will act as a simple support, and we know that at simple support the deflection will be 0. Now so we can take to make this 0 as downward deflection due to UDL without prop will be equals to upward deflection due to prop without UDL. So by taking this principle, we can make 0 deflection at the prop support. Now the value of prop reaction RB can be determined by this concept and by this deflection at free end, and the remaining reactions can be found with the help of simple equations of static equilibrium, that is summation of vertical forces equals to 0, summation of moment equals to 0. By using these two static equilibrium, we can find rest of the unknowns. Now let's see a simple numerical how this prop cantilever is going to be analyzed. So a cantilever or prop cantilever of span L, and this prop is provided at the free end, is subjected to a point load W at the mid span or midpoint of the span. Now find prop reaction. How to find? Also draw the bending moment and shear force for the above beam. So in this session we will only find the prop reaction, and next session, this continuation of today's session, we will draw bending moment and shear force diagram for this prop cantilever. So in figure you can see there is a cantilever, at free end B there is a prop support which is subjected to a central point load W, which is at a distance of L/2 from support A or fixed end, and the span is L. Now the downward deflection due to the point load or central point load W at free end will be obtained as WA cube by 3I. This is A, WA cube divided by 3EI, WA cube divided by 3EI. Okay, plus WA square by 2EI into B. Now in our case A, that is distance of the load from the fixed end, is L/2, that is mid span, then hence our A will be L/2 and B is nothing but total span minus A. Total span minus A is nothing but L/2, or it will become only L/2. Now by solving this, we will get that WL cube by 24EI plus WL cube by 16EI, or again by simplifying we will get the downward deflection due to the central point load at free end will be equals to WL cube divided by 48EI. Got it? कैसे आया WL cube by EI into 5 by 48? फार्मूला क्या है हमारे पास? In case of central point load on a cantilever, the deflection at free end is nothing but equals to क्या हो जाएगा? WA cube by 3EI plus WA square by 2EI in bracket or multiplied by B. This only this second term is multiplied by B. This we have already discussed in first module. Okay. Now this A is in our case is L by 2, and B will become also L minus L by 2 means only L by 2. So by solving we will get 5WL cube by 48 EI. Now what about the upward deflection due to the prop at the free end? So this prop will act as the point load at the free end, and we know for the point load at free end, the maximum deflection at free end in case of cantilever is obtained as WL cube by 3EI. In our case, this W is nothing but our prop reaction, means RB into L cube divided by 3EI. Okay. Now the prop reaction is determined by simply equating deflection at the free end due to central point load W with the upward deflection at the free end due to the prop. So we will get 5WL cube by 48 EI equals to RB into L cube by 3 EI. So by rearranging and solving, we will get prop reaction as 5 by 16 into W. That is, prop reaction equals to 5 by 16 times W. So likewise, we can find this extra reaction at the prop end in case of prop cantilever, or likewise we can analyze extra reaction. Hope you have understood. So in today's session, what we have learned? Yes, we have discussed what is prop cantilever, what will happen when additional support is provided, and how is going to be analyzed. So based on this, let's have a quiz or simple question. Hope you can answer. The support reaction at prop end for a prop cantilever subjected to central point load W. And options are WL cube by 2 EI, WL cube by 3 EI, 5W divided by 48 and 5W divided by 16. Just we obtain. Can you answer? बता सकते हैं इसका आंसर क्या रहेगा? सपोर्ट रिएक्शन एट फ्री एंड और एट प्रॉप्ड एंड subjected to central point load. Yes, option D is correct, that is 5W divided by 16. So based on today's point, in examination there may ask some questions. So these are the frequently asked questions on your screen. You may note it down. Define prop cantilever beam. Analyze the prop cantilever beam with a point load at the midpoint. So in next lecture we will continue this, in which we will draw shear force and bending moment diagram for a prop cantilever subjected to central point load. Thank you.